Here we have been given two blocks of equal mass connected by a light string that passes over a frictionless pulley. The angle theta in this case is less than 45 degrees and this angle is 90 degrees. Now it is mentioned that the blocks are sliding at a constant velocity and now we need to pick the correct options. Let's go option by option. Option number A. The net force acting on each block is the same. How do we do it? To find the net force, we know the formula F net is equal to m into a. That's the Newton's second law. F is equal to ma. So what is the acceleration of the blocks? So the key word here is the blocks are sliding at constant velocity, which means acceleration is zero, which means net force will also be zero. Now, since both the blocks are moving at constant velocity, that's why the net force on both blocks will be zero. And that's why the net force on each block is the same. And that's why answer is option A. But in any case, let us analyze the other options. Option B, the weight force acting on each block is different. So we know the formula for weight W is equal to m into g. Let me write that down. W is equal to m into g. Now it is given that the blocks are having equal masses, which means the weights will also be the same. That means option B is incorrect. The weights are actually same, not different. In option C, it states the magnitude of the normal force acting on each block is the same. Let's analyze this in a little bit more detail by drawing a separate diagram. We have to figure out the normal force acting on each block. So let's try to draw the free body diagram for both objects. Let's start with the left object. We have the weight of the object mg going downwards. Then we have the tension in the string which will go this way, and then we have the normal reaction. Let's call that as N1. Similarly, for the second block, we have the weight mg going downwards. The normal reaction will be perpendicular to the inclined surface. Let's call that as N2, and the direction of tension will be this way. Now we need to figure out, is N1 and N2, are they same or they different? So how do we do it? Again, we employ the same concept that the net force acting on the block is zero since they are moving at constant velocity. Net force being zero means this is an example of translational equilibrium. Hence, we need to balance out forces. How do we do that? If we look at this diagram, if we break the mg into two components, one component of mg will go along the incline like this, and one component of mg will be perpendicular to the incline. So if theta is the angle for this particular surface, so this particular angle will also be theta. Let's say this, which means now we can figure out the component of mg which is going perpendicular to the incline. So let me draw an arrow for that. So this component of the weight will become mg cos theta. And now we can see N1 will balance out with mg cos theta. Hence the equation becomes N1 is equal to mg cos theta. Now we repeat the same analysis for the second block. We have N2 going this way. Now N2 will be equal to the weight component which is going in this particular direction. So mg again can be broken down into two components. One component will be parallel to the plane. The other component will go perpendicular to the plane. Now, how do we figure out this particular component? For that, we need this angle. So if one angle is theta, the second angle is 90. So the third angle will be 90 minus theta. And how is it 90 minus theta? Since the sum of all three angles in a triangle is 180, that's why this is 90 minus theta. So if this is 90 minus theta, that would mean this particular angle, which I have highlighted here, this will also be 90 minus theta. And now we can figure out the component of mg which is going in this way. So that particular component, let us write it down. That will be mg cos of 90 minus theta. So this is the component of mg going in this particular direction, which incidentally is equal to N2. Hence, we will write down the equation for N2 equals to mg into cos of 90 minus theta. So we can say that N1 and N2 are actually different because look at the equations itself are different. Theta and 90 minus theta are different. Going back to the options, option C was saying magnitude of the normal force acting on each block is the same. That is incorrect because N1 and N2 are having different equations. Now, there is one possible case when N1 and N2 can be equal, when theta is equal to 45 degrees. And why is that? because if theta is 45, even 90 minus theta will be 45. In that case, n1 and n2 can be equal. In fact, n1 and n2 are equal to each other for the case theta is equal to 45. So we need to be careful in reading the question. Is theta 45 actually, which is given? So if I go back to the question, let's read. The angle is less than 45 degrees. So definitely not exactly 45 degrees. So N1 and N2 are not equal for this particular scenario. And that is why option C is incorrect. Coming to option D, magnitude of force exerted by the string on each block is different. We need to check, is that correct or wrong? Magnitude of the force exerted by the string, this is another way of saying the tension which is acting in the string. Now try to recall the logic of tension. The value of tension is the same as long as it is the same rope. So in this question, there are two blocks, but they are connected with one single string. And that is why the value of tension will be the same for both blocks. And that's why option D also is incorrect. And answer A is the right option.